You can if you want.
Kaden, no inappropriate questions, I mean. Oh, Haley's too sick. What did you even say that? What did you say?
Okay, so this, just so you guys know, is going to be the very last time I teach you guys this year. So this is our last section.
This is like a,
I know, it's sad.
this is like a heart-to-heart. Sad, yeah.
Yeah.
We're gonna have a quiz on this?
Oh yeah, we're gonna have a test on limits.
What? That's not the final?
Right.
That's what? I don't think that's gonna work out. Yeah, no.
So I know, good information altogether right there. All right, so this is how this works.
Okay.
First of all, we need to know what a derivative does. What it is, why we care about derivatives, okay? So a derivative is the first idea into calculus, okay? So the derivative basically helps us find rates of change. Have you seen that before? That phrase, have you heard of it? Seen it before? What is that in reference to?
Slope.
The slope. Okay, so we're talking about the slope. Now, so far, you have only used one type of function to analyze slope. What type of function was that? It was linear functions. Okay, so do you remember that on those linear functions, you're finding the change in the rise over the change in the run? So the change in y over the change in x. Okay, well, linear functions are very basic, okay? No matter where you are on your function, the rise over the run is always going to be the same. So for me to analyze my slope at that red point, what I would do is I would find a point on the left of it and then on the right of it and figure out what the change in the rise over the change in run is. Okay, well that's all fine and dandy, but how many linear functions are there actually in the real world? Like not very many. Okay, so we need to figure out how to find a rate of change of more complicated functions. Okay, we're not going to get incredibly complicated today, but the very next function that you ever learned about was quadratic functions. Okay, well, if you take a look at a quadratic function, does the slope always stay the same? No. Okay, if I was trying to analyze the slope of this particular point, okay, what I would have to do is basically pick a point that is on the left of it and pick a point on the right of it. And the goal here would be for me to get like infinitely close to that point. Do you see what I'm saying here? So I'm going to get really, really close to that blue point and then do a change in y over change in x. Okay, well, as I was getting infinitely close, what does that look like I'm kind of analyzing that we've just studied about? It talks about the limit. So remember when we were doing limits coming in from the left and coming in from the right? That's where limits have to do with derivatives. Okay, so we're using that idea of getting infinitely close to find the change in rise over the change in run. Okay, so I'm going to give you the definition, and this is something you're going to write down and highlight.
You just scored.
So it's going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so this has basically been derived from your change in y over change in x. Okay, they've simplified it to make it a little bit easier. I could go over the in-depth part of where this comes from, but I kind of have a feeling you are going to trust me on it. I mean, we could go over it, you guys.
No, I trust you.
No.
I should do all yours.
I appreciate that. Okay, so let's find the derivative of an example, like some quadratic piece. Nice. Okay, so I'm going to use the function, let's say x squared plus 3. Okay, so we are going to find the derivative of x squared plus 3. Okay, by using the difference quotient. Everybody ready? Okay, so let's make sure that we can see it. Okay, so it starts out, I'm basically doing that red equation, but using my f of x to kind of plug into that piece. Okay, so it's going to start out as the limit as h approaches 0. Okay, and then the first thing that it says up there is f of x plus h. So what the heck does that mean? What do I do with an f of x plus h? Okay, remember not too long ago, maybe a year or two ago, like what if I said, what is f of 2? What would you do with that? You plug 2 into the x, right? So you take that 2, you plug it in. Well, that's the exact kind of question that I'm asking you with f of x plus h. All I'm going to do is take x plus h and plug it into that x of my function. You see where I'm pointing? Okay, so I'm going to plug x plus h into the x. Okay, so all I've done so far is the f of x plus h. Now it says minus f of x. So if I subtract, what is my f of x? X squared plus 3. And since I'm subtracting a quantity, so stuff that has more than one term, I want to use parentheses, so I remember to distribute that negative through. Okay, and then it's all over h. Okay, so now we are at a place where we were in that last assignment. How do you find a limit? What do you do?
Plug in 0.
You plug in 0. So if I plugged in 0, let's see if we can do this mentally. If I plug 0 into the h, okay, I would have x plus 0, which is x. X squared is x squared. Well, you're ahead of me. You're ahead of me though. Slow down. Okay, so then I get x squared plus 3, and then I have minus x squared. So what happens there? They cancel, and then I have a minus 3, so the 3's cancel, so what's left on the top? 0. So I get 0 over 0. So I have to simplify it. Okay, so in order to simplify it, I'm going to start by factoring this. Actually, a different word. What are you doing? Don't touch anything.
I'm not.
Okay, so simplifying the top, Sid said factor, but we're going to undo factoring.
I'm pretty sure Olivia just did a home run.
Okay, that's great.
With loaded bases, like a grand slam, so it's like 6-0 now. No, sorry, continue.
Okay, thanks for the highlight. But we're going to undo factoring. We're going to FOIL. FOIL, okay? So do you remember that if I have x plus h squared, that's the same as x plus h times x plus h, and I FOIL it? So I would have x squared plus xh plus xh plus h squared. So that makes 2 xh's. You see where I'm going with that? Yeah. Okay, so if I FOIL that, we're going to have x squared plus 2xh plus h squared. Okay, then what goes after that? Plus 3. Then I have to distribute the negative, and this is where people make mistakes, distributing that negative. Minus x squared minus 3, there we go, all over h. Okay, so now I'm going to simplify the top. What do you notice about pieces on the top? We got x squareds going away. Adios x squareds. What else did you say? 3's cancel. So what I have left on the top is 2xh plus h squared all over h. Cancel, like, what do you mean by that? So there's a lot of scary spots right here.
Like the h squared, can it just be h?
Oh, like this?
Why not?
Why not? See that big fat plus sign right here?
Yeah.
Remember that if you divide by an h, you have to divide all three pieces by h. So, common mistake, don't do that. Bad, 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 bad. What do we got to do?
Well, can't you still do that and divide it?
Okay, you can divide all three terms by h, right? You got to do all three, though. So, really, what we should write is like, let's pull the h out of the top. Okay, like a greatest common factor. So, if I pull the h out, what's left out of 2xh? 2x. And then what would be left out of h squared? H, there we go. And now what can I do? Now I can cancel that h. All right, so how do I figure out the limit after I've done all this awesome simplifying? What do you do last? Good. So I get 2x plus 0, which I hope you all agree is 2x. Okay, so the derivative, which, by the way, the notation for that looks like this. It's kind of like a little apostrophe thing. Very similar looking to the inverse notation. The difference is -1. That's just like an apostrophe thing. So if you see that again, that's what that means. It's a derivative notation. All right, so 2x. What the heck does that mean? How does that help us in any way at all? We got a derivative, and now we got this new equation, 2x. Okay, let me try to explain this to you. Okay, do you remember our original function was x squared plus 3, right? Okay, so if I was going to graph x squared plus 3, what does that look like? A parabola that's moved up 3 units. Now, I'm not drawing this perfectly to scale, but that looks pretty dang good if I do say myself. Okay, so let's say we're going to find a point on that parabola. Okay, so let's say, I'm going to say, what is the point when the x value is 3? Okay, so I'm talking about this point right here. What point is that? So we plug 3 in. 3 squared is 9. 9 plus 3, 12. Okay, so I'm going to try to find this slope. So this, you basically have to draw like a tangent line. You guys remember the word tangent? So it's a different kind of tangent than the trig tangent. Totally different tangent meaning. Tangent means... Don't ask me, I'm not the math god. Tangent... Oh, thank you. Very nice compliment. Well played. So tangent in terms of lines means you only intersect the function or whatever you're working with one time. So like you might have seen it when you were working with circles some time ago. There were secant lines and tangent lines. So a secant would cross through a circle twice. Yeah, they do. So anyways, the tangent line only intersects, so it's kind of like perpendicular to that point. So if you were going to pinpoint that blue line and be like, oh, I wonder what the slope of that blue line is, what would you say? It looks like about, now I'm not a great drawer, so don't assume mine's drawn perfectly to scale by any means, but it's not that bad. 1 over 1? Really? Doesn't it look a little steeper than 1 over 1? 4 over 1? So just so you know, I can tell you exactly what the slope is. It's exactly 4. Okay, so all I have to do is I take this derivative and I plug the x value in of the point that we're analyzing, and I can tell you the slope of that blue line is exactly 4. Okay, what if we were going to analyze like way over here at like negative 4? That point way over here. Without using the derivative, what does that look like? Like it's steeper, but it's negative this time, right? So it's got to be less than -4 somehow, like negative well, yeah, like -8, right? So if I plug in -4 into my derivative, we could say the slope is exactly -8. Okay. Okay, so if you're taking calculus next year, you get to play more with this idea. We'll come up with the equations of tangent lines. We'll do more than just linear stuff. Yeah.
Why is it that little apostrophe times 2?
That little apostrophe means the derivative.
Why is it times 2? Because it's 3 to 1.
Okay, so remember when we found the derivative? That whole difference quotient?
Yeah.
That's the derivative. That's what I'm using now. So on all the x values that I'm using as points, I'm just plugging that x value into the x of the 2x.
So then why did you use -4?
I just picked a spot. I just wanted to be further to the left. I wanted you to see that it has a negative slope and it was steeper.
You're the teacher and you can't. That's always.
It's not always the answer, but it's a pretty good answer.
Didn't use examples.
All right, so let's do another example. Make sure we got this whole difference quotient thing under control. Our definition of a derivative. I keep saying difference quotient. Do you guys hear me saying that? Difference quotient. That's actually the same thing.
Why does everyone today?
Just the day we're doing. Just today. All right, let's do -2x squared plus x. Make it slightly more complicated. Okay, so difference quotient, you ready? Where do I start? Okay, I'll just give you a hint. It starts with the limit as h approaches 0. Okay, then what? You plug in what? Good, we start by plugging in the x plus h into the x. Now this time I have two x's. So I have to plug x plus h in twice. So -2 times x plus h squared plus x plus h. Okay, then what does it say? Minus f of x. Good, and make sure that you use parentheses because we're going to subtract two terms, right? All over. Are we supposed to include the x of the first one? Because, okay, so the function is x squared plus 3, right? So when I plug x plus h into my x, I still have the plus 3, like it's still the entire function. So I include it both times. On this one? Oh. Why didn't I include it? But I did. Because this part right here is my f of x, which is this. I don't understand what you're asking. We're not on the same page. Okay. We'll do another one and we'll see if we can get on the same page at some point. Okay. So at this point, what do I do? FOIL, distribute, simplify, right? Okay, so do you guys see how I have x plus h squared? And in the last question, we just FOILed this, right, Ab? Okay, so it was x squared plus 2xh plus h squared. Can you guys follow me if I do two steps in one here and also distribute the -2 through that quantity? Okay, let me know if this is too much. Okay, so if I distribute that -2, I'm going to have -2x squared. Okay, so then it would be 2xh. So if I distribute -2, be negative 4xh, and then minus 2h squared. Good there? Okay, and then I have plus x plus h, so I distribute my plus through, so plus x plus h. Then I have a minus through a second quantity. Again, I'm going to distribute that through, so what am I going to have as my last two terms? Minus x, good. Okay. So now I combine like terms. What do you see? The 2x squared cancels, right? The x's cancels. Have you figured anything out yet? Have you noticed anything spectacular?
You're always left with the whatever xh and
yeah, everything that's left always has an h in it. That's not a coincidence. All right, so let's pull out an h out of the top. Ready? This is a part where people get screwed up a lot. If I pull an h out of the top, what's left over of those middle pieces? Negative 4x minus 2h plus 1. Did everybody say plus 1? Because that's the part where people make mistakes. Don't forget that plus 1. Okay, so now my h's cancel. Can I go ahead and go to the part where I now plug 0 into the h? Okay, so I have negative 4x minus 2 times 0 plus 1, which becomes negative 4x plus 1. How do we do on that one? Not bad? Okay, I want to do one more with you. Last one. Number 3. This time my function is going to be the square root of x plus 4. Okay, so we can use this definition on any function. Okay, and they can get super complicated. We won't go super complicated this year. We'll get super complicated next year. Yahoo! All right, ready? The limit as h approaches 0. What do I do first? Plug in the x plus h. Good. So I have x plus h plus 4. Now, is everybody okay with me not putting parentheses in there? Because I'm just going to add everything anyway, so they'll just kind of pop away. Okay. Minus, then what? Good. Okay, all over h. Shell. There's no parentheses here. We can't FOIL stuff. But we did do a problem like this on the worksheet. Do you guys remember how we work with square roots? Square it? No. Not a bad idea. But how do you get rid of square roots? Now wait a second. You literally square it. So you're telling me that if I have, for example, 2 fists, and I square this, I'm not going to change its value? So can we square a top and a bottom? No.
Oh, you square.
4 25ths is not equivalent to 2 fists. No. Not happening. They're not the same.
Okay.
We can't square a top, we can't square a bottom. No. It has a cool name.
Oh wait, you multiply by the square root of the square root.
Yeah, that's getting closer. So do you remember you multiply by the conjugate? Remember the conjugate?
No.
Gosh, you guys don't remember any of the cool words.
Sounds like a horror movie.
Okay, so x plus h plus 4 plus the square root of x plus 4. So the conjugate is basically the exact same thing, but you change whatever's in the middle to a plus or a minus, whatever it happens to be. Conjugates. Ooh, conjugates are awesome. Uh-huh. All right, so
Shoes?
hold on. We'll talk about it in 5 minutes.
Sorry.
Focus. We're almost done. Okay, so we're going to FOIL the conjugates, not the non-conjugates. Okay, so we're only going to FOIL the top here. Okay, so if I have a square root of x plus h plus 4 times the square root of x plus h plus 4, what am I left with? Yeah, they square and the square roots cancel out, right? So it's just x plus h plus 4. Okay, and then you remember when you multiply conjugates, the middle terms cancel out. So then you just have the last one. So now if I multiply a negative square root of x plus 4 times a positive x plus 4, I am left with. And when you say x plus 4, you are not saying parentheses, but we have to write the parentheses because it's being subtracted. X plus h plus 4 over. Okay, so now on the top, what do you see? Does anybody see x minus x? Okay, adios x's. Does anybody see 4 minus 4?
Yes.
Adios 4s. So what's left on the top? So what can I do? So if I cancel the h's, what's left? Good. Can't believe how many people say that this just cancels out and you're left with the bottom. No, there's 1 on the top. All right, I simplified. Now what do I do? What's that? Ooh, icky. Don't do that yet. We're not going to make this too bad. Let's take the limit part. Okay, so we're going to plug 0 into my h. So I'm going to take the limit. So it's going to be 1 over. Can I go ahead and say that the first one, since I have x plus 0 plus 4, is just going to be x plus 4? And then plus the square root of x plus 4. What happens if I have x, the square root of x plus 4 plus the square root of x plus 4? There's 2. Okay, and we can leave functions with square roots in the bottom. Okay, when you get into calculus, they allow you to keep the square root pieces in the bottom because otherwise it can get incredibly complicated. So kind of a general rule with that square root thing is if it's an x, you can leave it. But if it's like the square root of 2, then you guys simplify it if it's a number. Okay. Awesome. Got it, Garrett? Feeling good?